Okay, so I thought today for fun, I would show something cool off on our private cloud. Um, we have a private cloud at UCL, and I've done videos about that. We called it Condenser because it's, taking the cloud and condensing it. It's a very large system with about 8,000 cores and a bunch of GPUs, and it's based on SUSE harvesters, hyperconverged infrastructure. And we use this for hosting services, and I use it a lot for teaching. It's very nice to be able to give students a cloud environment where they can mess around without breaking things. But most of the stuff we do is based on Linux, right? And that's because Linux has kind of become the default operating system for everything, right? Certainly on the server side, on the HPC side, on the cloud side. Um, but one of the features of Harvester is, of course, because it's based around Kubernetes and KubeVirt, is that you can run other operating systems on it, right? Theoretically, you could run Windows on it, but I'm really unsure about the licensing situation there. For those of you who don't know, universities have like site licenses for Microsoft products, but they usually rely on you having an existing Windows license, which is inherited and sort of extended into the site license. And I'm pretty sure none of our servers have ever had a Windows license. So to avoid like violating Microsoft's horrendous licensing agreements, let's look at a completely different operating system. It's still a Unixy operating system, and it's actually related to the system I used when I first started using Unix myself in sort of anger. And it's this thing called BSD. And so BSD, I've got a flowchart on the screen from Wikipedia, kind of shows the lineage of Unix and Unix-like operating systems. And you can see, for example, that Linux is its own sort of column of history, right? It's completely, although it implements many of the same interfaces as Unix, it's an entirely a re-implementation. BSD, which comes out of the University of Berkeley in California, is really genetically related to real Unix, right? But there was this in early Unix, there was this difficult legal situation where people were passing around tapes of AT&T's intellectual property, extending it and then passing around. BSD kind of came out of that, and at some point there was effectively a re-implementation of a lot of the stuff. So BSD is like not legally Unix, but sort of genetically related to Unix. And so when I started out learning Unix, I actually started out rather than Linux, as a lot of people, with an operating system called NetBSD running on Spark. Um, and previously, I've actually got that running on our cloud, but um, NetBSD is very much designed around portability and sort of smallness, elegance, neatness. And so it doesn't talk very well to things like cloudinit or the QEMU host utilities the QEMU guest agents that we need to have to make our cloud work properly. So I thought it would be nice to try something else. And if we look down the tree that NetBSD is in, um, there's this other operating system that forks off BSD called FreeBSD. And FreeBSD, I would say of like the main BSDs that you can run today, there's kind of OpenBSD, which is very security focused, NetBSD, which is very focused on portability to different hardware. Like famously, NetBSD basically runs on anything. FreeBSD is the most sort of, I don't want to say friendly because that can sometimes have negative connotations, but like the most Linuxy, like comprehensive of the BSDs. And FreeBSD does in fact now have support for cloudinit, and cloudinit is an important part of how our systems build VMs. So what cloudinit is, it's a product originally designed by Canonical. It lets you like preload some configuration into your VM. So maybe some stuff around networks or user accounts. And that allows us to do some nice things in terms of setting up, pre-installing key users' SSH keys into VMs so that we don't have to pass passwords around. Um, and so, okay, so we're going to do FreeBSD. What do we need to do? Well, obviously, we need to have an account on the cloud, and I do. I'm going to be doing this from the tenancy that I use for teaching, just because it's a nice isolated little bubble of the machine. And here we are logged into what I call my command and control machine, which is a VM called Nurgle. And so we can have a look to see what's actually running in my tenancy at the moment. Right, so remember, Harvester is just Rancher and KubeVirt and some other products, so we can control it with kubectl. And we can see that I've only got a single VM running, which is this one, which is Nurgle. And so what we want to do then is you use the kind of software-defined infrastructure tools that we'd use for provisioning a Linux VM to provision a FreeBSD one. So the first thing we have to do, as I Alt-Tab through various things to try and get the right Firefox window, is we need to get a copy of FreeBSD. Now, if you want to download it with support for cloudinit, if you actually look in the section for AMD64, you'll see there are these cloudinit images here. And so you want to pick one of these, right? We want a QCOW2 because we're using KVM, but a RAW would work as well. I'm going to use UFS just because that's the file system I remember from when I did NetBSD. It has a UFS drive file system, but you could also do ZFS as well. So what you need to do is download this, decompress it, and then put it into the image store in Rancher. So let me pull up a Rancher window on the other browser where I'm actually signed in. Okay, and you can see what I've actually done here. Oops. Try to get the user interface to work. So here where I'm signed in, I've uploaded that image, right? One of the things that's slightly annoying is that this image is exzipped, and Rancher doesn't like exzipped images, so you will need to unexzip it and then load it in as an image. So having done that, we have an image in my tenancy, and we can use that to build the VM. So I have learned through long and painful experience that it's quite good rather than good behavior, rather than editing and modifying sort of the setup for a VM inside the Git tree that you're using, to pull it out and have either a different tree or a different folder where you can make your changes without it being a mess when you try to pull new versions of things. And in my sort of set of repositories for my own personal use, I have a bunch of I have a bunch of Terraform plans and Ansible. My brain tries to remember what playbooks, that's the phrase, for my own, which allow me to build things. And so in here, I have created a Terraform plan. I'm actually going to use Ansible because I've not done Ansible with FreeBSD yet, but a Terraform plan which actually allows us to build the system, right? And so actually, if you've used any of our infrastructure before, the sort of main plan is pretty much the same as every other one we use. There's no difference for Linux or FreeBSD. The main difference being actually you do need to make sure that secure boot is turned off, because unlike Linux, FreeBSD doesn't provide a signed kernel that and a signed bootloader that your system will recognize. And really, the only really special bits in the Terraform part of this is making sure we use that specific image. The other thing we need to do is have a much more complicated cloudinit template, and that's because although the cloudinit images support cloudinit, there's some like interesting security choices made by the FreeBSD team which make it a bit awkward. Specifically, you can log in on the console of the VM. Certainly in our clouds and in others, you can connect to the console, and by default, root has no password, and you can log in as root on the console. Which would mean other people in your tenancy could log in as root, right, while the machine was being set up. So we don't want to allow that. So I spent a lot of time. The cloudinit in FreeBSD is a bit unusual. I don't think it's a direct port of Canonicals. I could be wrong. And so I spent a lot of effort trying to make it behave, like build a cloudinit template that would make it behave like a Linux system. So what do we want from that? We want to have a low privileged user who can sudo, basically, and we want to prevent root logging in on the console without a password. So after some messing about, the way I achieved this is to make sure we install the QEMU guest agent and install sudo, right? Want to make sure we turn off password-based authentication, because again, we don't want that, although SSH generally doesn't let you log in with an empty password anyway. Let's just belt and braces it. So we're going to create a user, we're going to call it FreeBSD. this is actually, although this is a YAML file, it's a template for the Terraform code to build. So you want to make sure we put in the SSH key that we will pass through Terraform into the cloudinit file, and we're going to put it in wheel. That's so that it can sudo. And then once that's done, we want to make sure that once the system's built, it prevents either of these users from logging in with a password. So neither root nor FreeBSD will have a valid password. On Linux, you do this by locking the account. But on FreeBSD, it uses a different tool here called PW. And if you lock an account, it genuinely locks the account. So locking the account on Linux usually puts like double exclamation marks or an exclamation mark at the start of the password hash, which means that it is on, you can't, there's no string that will hash to that. That prevents you logging in with passwords, but you can still log in with SSH or with SU. PW, if you lock an account on FreeBSD, actually prevents you becoming that user at all, which is actually super cool. But what we actually want to do though is blank out the password, and we do that with -w no. And this final thing we want to do as part of the setup is make sure that we tell it to start the QEMU guest agent on boot. We also need, part of getting both those things to work is we want to make sure that users who are a member of Wheel, so that's the FreeBSD user, can sudo without a password because they don't have a password. And so if they don't have a password and they're in the sudoers and they need a password, they can't sudo. So we want to make sure that they can sudo without a password. And the final thing we want to do is so these two steps here, this is the equivalent of on Linux doing systemctl start QEMU guest agent. And this is the equivalent of systemctl enable QEMU guest agent. Right? We make sure that you add this into rc.conf. And if we do that, we start QEMU guest agent. That allows it to talk out and give all the sort of rich debugging information and tell Rancher the IP addresses and all the other things that we want it to do. And then it will also work when we reboot. So we have to have a more complicated cloudinit template. I mean, as an example, I'll show you what it looks like on AlmaLinux, right? This is a lot shorter. But that's just because we want to make the system behave like one of our Linux systems in terms of that setup when you first get it built. Okay, so how do we deploy that? So I've got my repository, I've got my Terraform. Generally, what I would do, again, just to be neat, is I take a copy of that directory, base environment, here, and we'll call it a video BSD. And then what you want to do generally is variables.tf contains like user specified variables, and we want to set that up so it's correct for what we want to do. Let's edit that. So the image is correct, but actually a bunch of stuff here is incorrect. So we want to make sure this represents the namespace we're in, which, because we're going to use my teaching dependency, let's do that. Okay. And similarly, we need to set the network so it's inside that network. And then we also want to set some other variables. So for my VMs, I have a variable called username, and that doesn't change the user that's provisioned. What it does is it tags the VM with your username in its part of its name, so that it's easy to see if you're in a multi-user tenancy who a VM belongs to. And then finally, we want to give it the SSH key that it's going to provision in. And because we're going to log in directly from my MacBook, because we're not using Ansible on Nurgle, I'm going to tell it to provision with the key in Rancher that's for my MacBook. And having written that out, we then do the normal routine of Terraform init, which sets up Terraform. Make sure we have all the plugins. We need the Harvester plugin, and then we do Terraform apply. Ah, no, I've made a typo. Let's have a look. Ah, there we go. Intentional error. Okay. There we go. So it's important that when you put in the fields, things like what the network is, these are resources that exist. The same with the SSH key. If they don't exist, Terraform will error like that, and you need to fix your plan. Now, what's actually happening? So this is because we have to do so much in the cloudinit stage, which is something I don't really like because cloudinit is a bit opaque sometimes. You know, the machine starts up, cloudinit starts, and then a whole bunch of stuff happens in the background. Um, Normally that's quite annoying because on Linux in particular, the first time when it does cloudinit, like it carries on in the background and the boot process continues. One of the things I noticed about the way FreeBSD's cloudinit is implemented is actually the machine doesn't really get into like a functional multi-user state until after cloudinit is finished, which is good because of all the password shenanigans we've been talking about. It does mean it takes a little bit longer for the VM to complete because Terraform sees the VM has completed when the QEMU guest agent talks to it. And as part of the system setting up, the QEMU guest agent has to be installed and started. What we can actually do, I'm going to bring up the user interface now on the other browser. And I should be able to open the virtual console of this machine so we can see it doing its thing. What's happening now, it's installing Python 3.11. That's a dependency for that QEMU guest agent, apparently. So, I mean, some interesting things have already happened right now, right? So, the machine has booted successfully. It's got a DHCP address successfully. So, all the networking hardware, the virtualized networking hardware is working on the machine. And it's managed to download and install packages. This console is sometimes not super good. I might bring up the serial. Like there's an alternative to the VNC one. There's a serial console as well, and actually you can use KubeVirt to KubeVirt to actually get the serial console in a terminal if you want. So the machine has finished installing. It's installing sudo. It's done all the stuff with the keys, and the machine is now up. Now, if we hadn't done the shenanigans with cloudinit, we could now log in without a password, but we can't now because root has been told that it can't. So we have a machine. It has an IP address, and what I'm going to do, if you remember, I set it to use my MacBook's H key. So coming over to my MacBook, the first thing I do is make sure that I don't have, because we're generating machines all the time. There's a reasonable possibility that I will have this key in my known host. So let's just make sure we don't. Okay. Okay. Sorry, it's been a long day. And then we want to log into FreeBSD at, and then this IP address. So this is an SSH jump box, right? And so we connect through that. And the reason we do that is A, we want to protect the various VMs from direct connection, but B, we enforce multi-factor by the use of short-lived SSH certificates. So what do I mean by that? Well, we have a service which is a web service that will sign keys for you, and it's based on logging in through MFA through your Microsoft account. And then that allows you to jump through the SSH proxy. You can also use it directly with the Vault client, which I used, because then you can just do it from the command line. But that still requires you to do that MFA step in your browser. So now we log into that machine. So it goes through the jump box, and then it hasn't seen this FreeBSD machine before, so it asks for a key. And we're logged into FreeBSD, right? So it's FreeBSD. What can we do? Well, first thing we should probably do is install any security updates, because if you are aware, if you've been following these things, there were some very interesting security holes in FreeBSD discovered over Christmas. So let's do that. Let's first of all, so to that we need to be able to sudo, right? Which we can do. And then we do package update to get the up-to-date list of packages. This is actually slightly unnecessary because it will have been done as part of the install when we did the cloudinit. Do package upgrade to install the updates. And we see, unsurprisingly, there's a bunch of fixes for the kernel and the utilities, which I suspect are related to the security problems. We actually remember we ran that kubectl command here on the other terminal. We actually see that we get information back, like we can see the IP address. If we actually look in the Rancher GUI, as he tries to find the right Firefox, say web user interfaces really make me uncomfortable with like their inability to cope with clicks properly. JavaScript is a lot to answer for. Well, that loads. So if right to its own window, we can see actually in the Rancher GUI both those VMs. And if we look at the FreeBSD, when you see it's prepended my username into it, that's because we set that in Terraform. But if we look, the QEMU guest agent actually reports also all sort of information about the machine that we would like. So it reports that it's running FreeBSD. Right, has this finished? Right, the update's finished, so let's reboot it. And that machine should reboot. Oh. We bring back that console. And it's rebooted, so we can log back in. Okay, and then it is genuinely a FreeBSD system, right? So we can install a bunch of, so let's install some compilers, Vim, new screen, compile like the canonical Pi example and run it on FreeBSD. Okay, so what do we want to do? First of all, I want to install Vim and screen. There's an annoyance with the way the default configuration of Vim and screen on FreeBSD, which means the mouse becomes quite annoying because the way it does copy and paste. So the first thing I'm going to do is I'm going to put a setting in my .vimrc. Oops. Okay, just so that once we've installed Vim and screen, things are not annoying. And then we want to do sudo pip package install screen and Vim and git and cmake. And we also want to install the GNU compiler set, and I cannot remember what the exact package name is. Hang on. This package here installs the standard GCC if you're a version of FreeBSD in this case. So you want to install that as well. So that is GCC-13_5. Okay, so we've installed those packages. Let's get a Git repository. So we have, as he tries to find the right window, a Git repository. Which you've probably seen before if you've seen me do videos, which has a lot of like really awkward ways of calculating basically the same algorithm for calculating pi, but in lots of different languages. Right? It's not a very good way of calculating pi, but it's nice and it generates a sort of nice sized chunk of work to demonstrate parallelism. So let's get that. And then let's build the Fortran OpenMP version. Oops. And we'll do it with CMake because I hate CMake. Of course, now if we just run that, no, we need to actually do a make. And now run our code. Right, so we have our little OpenMP program. All good. Okay, so yeah, it's an operating system. This is something you can't do in containers, right? Containers don't let you run a different operating system inside a container. They let you run like a different userland and a different libc, so you can try out the sort of like the distribution part of a different Linux. I guess you would say operating system, but you can't run a different kernel, right? And so what's happening here is this is a completely different operating system, and it's not Linux, and you can run it on our cloud. You could run NetBSD, OpenBSD as well, although their cloudinit support is not so good. It's actually not the cloudinit. It's so in order for QEMU guest agent to talk back to the hypervisor, the kernel has to support like a virtualized serial interface, and there just isn't support for that in the kernels of those two operating systems, as far as I can recall. At the moment, it might be true. It might not be true in OpenBSD. Actually, I've not tried it. But FreeBSD kind of has the package of both a working QEMU guest utilities, a working cloud in it, which means it's just as controllable as Linux, right? Um, so the final thing we should do, of course, is destroy this machine. So let's do that. And it has died. If you go back here, we've been logged out. And it's gone. If we do cube, I'll get VMIs. Gone. Okay, that's it for this video.